Okay, let's talk exams. They can be pretty tough, right? And a lot of the time, it's not just about knowing the answer, but knowing how to write it down to get the marks. So today we're going to put on our examiner's hat. We're taking a real GCSE question and we are going to pick it apart piece by piece to see exactly how it's marked. Let's get into it.
So here's our setup. This should look pretty familiar. It's a classic school lab experiment. We've got some zinc reacting with sulfuric acid and it's bubbling away, producing hydrogen gas, which we're collecting. The entire exam question we're about to deconstruct is based on this one reaction.
All right, here's our game plan. We're going to break this question all the way down. We'll look at how to get that first easy mark, tackle the big calculation, think about changing the conditions, and then nail the chemical test. By the end, you'll see exactly how a mark scheme works. So just for context, we're looking at question 1 from the AQA GCSE Chemistry higher tier paper from June 2023. Our goal here is to really get inside the examiner's head and figure out not just what they're looking for, but why they're looking for it. Okay, first up, part 1 of the question. This is a nice, straightforward one-marker. These are the kinds of points that are easy to pick up as long as you've paid attention to the details of the experiment. The question is, suggest why the stopper must be put in the conical flask as quickly as possible. So think about it. The second that acid hits the zinc, the reaction starts. Bubbles start forming instantly. So if we're slow with that stopper, what are we losing? And there it is, the exact phrase from the mark scheme, to reduce the escape of gas. Simple as that. Using precise language like this is exactly what gets you the mark. It shows you understand the practicalities of the experiment. Now for the big one. This is a 5-mark calculation question. For these, showing you're working isn't just a good idea, it's absolutely essential, because there are marks available for every single step to get right. So, the task is to find the mean time. But look, there's a really important instruction there in bold. Do not include any anomalous results. That's a huge clue. It means we first need to spot the difference with the data and get rid of anything that doesn't fit. And here's our data table. Just have a quick scan. You can see trials 1, 2, and 4 are all pretty close, right? But then there's trial 3, 0.68. That one's way off. That's our anomaly. So the very first thing we have to do is identify it and just ignore it. Let's walk through how to bag all 5 marks. First, you add up the 3 good results and divide by 3 to get your mean rate. That gets you a mark. Next, you need the right equation, and then you have to rearrange it to solve for time. Each of those steps gets you more marks. Then you plug in the numbers. You see, you're building a case for the examiner, showing them you know exactly what you're doing. But here's something you've got to know about mark schemes. There's often more than one way to get to the right answer. Examiners are trained to accept any scientifically correct method. So let's look at the other way you could have tackled this. This approach kind of flips the process. Instead of averaging the rates first, you work out the time for each individual trial, and then you average those times at the end. It's a totally different route, but it's just as valid. And what do you get? 25 seconds, the exact same answer. The big takeaway here is that showing your logical steps clearly is just as important as getting the final number right. Okay, we can put the calculator away now. The question is about to shift gears. Now it's going to test our knowledge of what actually controls the speed of a reaction in the first place. Now, you have to read this one carefully. It's a little bit of a brain teaser. It asks what would increase the time. Think about it like you're running a race. If you want to increase your time, you have to run slower. So what this question is really asking is what 2 changes would slow this reaction down? And the 2 correct answers are using a lower temperature and using acid with a lower concentration. It all comes down to collision theory, right? If you cool things down, the particles move slower, so they collide less often. And if you lower the concentration, there are just fewer acid particles around to collide with the zinc in the first place. Both lead to a slower reaction. And for the final part of question 1, we've got a true chemistry classic. This is the test for hydrogen gas. This is one of those facts you just have to have locked away in your brain, ready to go. The question says, describe the test for hydrogen gas. Give the result of the test. Notice that it's a 2-part question, which is a big hint that you need a 2-part answer to get both marks. 1 part for the test and 1 part for the result. So here's how you get both marks. First, you get a mark for the test itself. You have to say you'd use a lit splint. The second mark is for the result, the famous squeaky pop. But, and this is crucial, the mark scheme is clear. You cannot get the mark for the result unless you've described the correct test first. It's a package deal.
And this right here is why understanding the marks game is like having a superpower. It shows you exactly what wording is okay. Flame is fine, but glowing splint is a definite no-no, because that's the test for oxygen. Pops is okay too. Knowing these little details makes all the difference. So, we've broken down that entire question. What's the big picture here? What are the key things you should take away from this that will help you in your own exams?
It really boils down to this. First, read every single word of the question, especially instructions like exclude anomalous results. Second, always show your working and calculations. Third, make sure you understand the theory, like how temperature affects reaction rates. And finally, learn the precise wording for those standard chemical tests.
I think this quote sums it up perfectly. Your real goal in an exam isn't just to jot down the right answer. It's to prove to the person marking your paper that you actually understand the science and the process you used to get there.
So I'll leave you with this to think about. Now that you've seen behind the curtain, you know exactly what an examiner is looking for and where every single mark comes from. Would it change how you approach a question like this next time?